Okay, hello everyone. What I want to do first, so it shouldn't be too long. We'll see how long these videos go, but I'll try to keep it under 20 minutes. I want to finish the problem that we were working on in class. I want to finish that problem, which was example 5 from 5.2. So you might want to pause the video, and I actually wrote out what we did in the 1 o'clock session. So the 9 o'clock, I think we did something different. So if you finish that on your own, then that's fine. I just want to show you the left-hand side, and then I also want to show you the right-hand side of this proof. And then I want to do a couple more verifying. And then in this video, I'll give you the problem for the quiz that you need to do. Okay, so we had to verify that the quantity secant x minus tan x squared equals 1 minus sine x over 1 plus sine x. And so how we started it in the 1 o'clock session is the following. So right away, we work with the left-hand side, and then right away, we rewrote secant x and tan x in terms of sine and cosine. So once we did that, then we noticed that they had a common denominator. So that means we could bring the numerators together. And so inside the parentheses, let me go back. So, and we also notice it's squared there. So the numerator becomes 1 minus sine x squared over cosine squared x because you square the denominator. And so I might skip some steps. In your notes, you should complete those steps just to make sure you go step by step. But to save time, I skipped a couple steps. Then from there, and remember what I said, I don't know which class, but remember I talked about sometimes when you're multiplying, don't multiply it all the way out right away because you may see something, which is what's going to happen with this left-hand side. Okay, and so from here, so from this line, we went to the next line, which we kept the numerator is 1 minus sine x squared, but then the denominator is the identity. We can use cosine squared x. Well, since the denominator is cosine squared x, we can rewrite it using Pythagorean identity and rewrite that as 1 minus sine squared x. Now, note that this is the difference of squares. Okay. And so, if we continue on, we will have the numerator 1 minus sine x squared. Well, we can write that as 1 minus sine x times 1 minus sine x. Always keep in mind when you're trying to go, because you can try different things with verifying identities, but always keep in mind where you're trying to go. And since the new denominator is the difference of squares, we can rewrite that as 1 minus sine x times 1 plus sine x. And since this is all multiplication, that tells us that we can factor. So we're going to factor that 1 right there, and we have 1 minus sine x over 1 plus sine x. And this is your right-hand side. Okay, so not bad. Now, let's go with the left-hand side. Okay, so this is where we have 1 minus sine x over 1 plus sine x. So make sure you write these in your notes, just so you'll have more examples to work from in terms of looking at section 5.2, since when I come back on Tuesday, we're going to 5.3. All right, so here, the conjugate that I was talking about in class, we can use the conjugate. So we multiply the top and the bottom by 1 minus sine x. Okay, and then this would equal, if we multiply, now we're going to multiply that through because look at where we're trying to go. We're trying to get the quantity secant x minus tan x squared. So this is going to be 1 minus 2 sine x plus sine squared x all over 1 minus sine squared x. Well, I just want to change up the color. So now, what we can do is break up our well, before we do that, let's rewrite this 1 minus sine squared x using Pythagorean identity. If we do that, it becomes, very good, cosine squared x. All right, so let's see. So sine squared x all over cosine squared x. And now what we can do is break up that numerator. So we can do this. So this is legal algebra. It becomes 1 over cosine squared x minus 2 sine x over cosine squared x plus sine squared x over cosine squared x. All right, change that color again so we keep going. And now that first term, 1 over cosine squared x becomes secant squared x. That middle term is just minus 2 sine x over cosine squared x, I should say. And then that last term turns into tangent squared x. Now, so this becomes secant squared x minus 2. And I'm going to break this up because I know where I want to go. I'm going to break this up into 1 over cosine x times sine x over cosine x. So I'm not changing anything. It just looks different. And then plus tangent squared x there. Okay. So this equals secant squared x minus 2. 1 over cosine x is secant x. And sine x over cosine x is tangent x. And then I'm going to have to write on another line plus tangent squared x. And what's going on is this. What we're noticing, well, what we notice is that, okay, we're trying to show, so here's where, and I don't know if I stated this in the second section, the 1 o'clock class, but I know I stated this in the 9 a.m. class. Sometimes you get to a point, so let's say we continue here and we get to this point and now we're stuck because we know we want to show, we know that, let me make it, I'm sorry. What we know is this. We know we're trying to show so I started this off. I should have said right hand side. So that was my mistake. So this is the right hand side. And we're trying to show the left hand side, which is secant x minus tan x squared. Okay. So sometimes when you get stuck, so let's say you're going and doing one side, and if you get stuck, you can start the other side. Now you can't move things over to other sides. You can't do that because it's not an equation. But if you get to a point on one side and you get stuck, you can go to the other side and see if you can break that other side down further and see if you can find a point where they're equal, because then you can show it that way. So here, if we were to distribute or multiply this expression out, secant x minus tan x squared, then this would equal secant squared x minus 2 secant x tan x. I hope you can see this because I don't want to move to a new page. Plus tan squared x. And now this equals the right hand side. Oh no, sorry. Let me go back. Since we're starting with the left hand side. Notice now, because we extended that left hand side out, we extended it to secant squared x minus 2 secant x tan x plus tangent squared x, which is the same thing we have here. So now we can say this is the left hand side because we extended it out. You can't jump from here to here until you extend it out or show me that you're extending it out. But you can. So this is a valid method. So if you start on one side and you get to a point where it's just going to get more complicated if you try doing more things, see if you can start. If you can, sometimes you can't start anything with the other side, but in this case we can. So we started some with that side and show, well, at some stage of the right hand side, it actually does equal the left hand side. And that's at this stage right here. Sorry. This stage. Okay. And so then we're done. All right. So I'm going to stop this video here. And then on the next video, I'm going to do a couple more examples and give you your quiz problems.